Welcome to Talkin Science, where we dive into the stories making headlines in the world of science and space. I'm Matt Miller. Dr. Brad Tucker is here. Brad, happy Tuesday.
How's it going?
Really good, my friend, really good. Let's get the headlines in this, the 27th week of 2021. They made it. Richard Branson and the crew on Unity 22 make it to suborbital space, successfully completing an almost 2-decade-long ambition. A Hypernova discovery from the very early universe. And 4 rogue planets found out in the cold depths, separated from their parent star. Well, we're in the depths of winter, Brad, but when the cold, clear nights are around, what's in store for some telescope viewers?
Yeah, look, cold means clear, which is always the good thing. It's a great time of year, actually, to see Jupiter and Saturn, to be honest. They're starting to come up relatively early to be able to spy in, and you have the Milky Way, so it's usually a good combination to get all 3 of those objects.
Absolutely. Get out there with the winter woolies and have a look at the night sky. Well, before we get into the show, a quick reminder of the socials. We can find you on Twitter at btucker22. I'm on Twitter at Merrimat86, and of course Trekzone exclusively on Twitter. Plus, find our YouTube channel for the latest eps and on your podcast app of choice. And don't forget, I've been banging on about it for a couple of weeks. Trekzone membership is available right now on YouTube. Underneath every video on our channel, you will see join if you haven't joined already. Click that button, and for less than a cup of coffee a month, you can support Trekzone, make more cool podcasts like this, and try our hand at another Canberra road trip sometime soon. You can also jump onto the trek.zone/support or put your phone up to the QR code on screen throughout the show. Brad, first up in our headlines, the cause of Hubble's glitch a few weeks ago still hasn't been identified, let alone fixed.
Yeah, look, it's becoming, obviously, it's always been a serious problem, but they were really hoping that they could have nailed it down by now, and they haven't. And now the policy kind of is to take it slow and steady, really. They realize that it's always complicated, but there was not an immediate solution to this. And it's going to require some fiddling with systems, and still fiddling with systems that they're less familiar with, less used, which means that it's going to take a bit more time. And so instead of rushing something, really just slowly take their time. Now, obviously, you want to get it back online as quick as possible, but getting it back online at all is the key here, which is what their goal is.
Absolutely. Fingers are crossed here at Trekzone. Well, methane wafting from Saturn's moon Enceladus could be an indicator of life in its subsurface sea, Brad.
Yeah, we've talked a lot about Enceladus before, and with the Cassini flyby back in 2017, it saw hydrogen gas shooting out of the cracks. It also detected methane. But yeah, this new study has really shown that, well, maybe this methane statistically could have come from a biological process. Now, they do say that there's lots of things that could have created it, but essentially trying to apply some mathematical models to say, what is the likely culprit until we find it? So it's just one of the, this body of evidence that keeps building and building and building to show that, yes, maybe there is life on these moons of Jupiter and Saturn.
Well, let's head into our stories of the week. And Unity 22 has made its flight to suborbital space. 80 Ks up for 90 minutes. It's a big milestone, Brad.
Look, a milestone almost 2 decades in the making. 17 years, $1 billion of his own dollars, essentially, to get this. And say what you want. There's a lot of things that people are talking about. It's just a billionaire race, and how is the average person going to do it? Ultimately, Richard Branson kind of created this idea that you can have tourists in space, and that more ordinary people. And someone will say, well, 250,000 isn't ordinary. Well, yes, but the Russians only took people who could pay $30 million, which is very not ordinary to the average person into space, and really trying to change the paradigm of how space travel happens and who does space travel. And look, kudos to him for seeing it through. And I think that's the big achievement here.
Well, Brad, you mentioned it there just now. It leads into my next question. With that feedback on social media, people saying that billionaires like Branson, Musk, Bezos could be spending their money on solving the problems affecting humanity right now, instead of this billionaire race that you mentioned. But, we both agree in the past that pushing forward in space does have reverberations here on Earth. Do you think space tourism achieves that same goal though, Brad?
I think there's indirect consequences that maybe haven't been as publicized. A great example is that the money from these companies and the technology developed is really going through to developing ultimately cheaper rides of anything into space. And I think that's the key. Human or satellite, it's almost the same to put it up. You actually have to be a little bit more safer, so to speak, a little bit less risk with humans, and that's a good thing. But if we think about the costs of putting things into space, 5 years ago even, it was still $20,000 per kilogram. So if you wanted to put a 10-kilogram satellite, it's $200,000 just in the cost to get it up there. This has now changed. It's currently sitting, around $1,000, and it could get into the next few years as cheap as $100 per kilogram. You're literally talking about, hundreds of times cheaper to put something in space now, because they built reusable systems that can also take people. And so I think this is a consequence people aren't appreciating, that that reusable, accessible, cheap system means that it's also reusable, accessible for the satellites that we have desperately grown dependent on in our everyday lives. We couldn't have lived and survived as well, quote unquote, we'll say that, in 2020 as we did if we didn't have a hyper-connected world.
Exactly right. And I think also too, I was listening to a interview on the BBC in regards to this as well. And it's not just the cost of getting stuff into space, but it's that experience as well. And, what you alluded to there with satellites, we don't necessarily care too much if they blow up. It's a bit of a problem if they do. But, if humans die on the way to space, that's an even bigger problem. The more launches we do with the more people, obviously more experience, and it's going to be an easier, quote unquote, way into space and paving the way forward for our species.
Yeah, and a couple of astronauts even have always talked about, well, there's the overview effect, right? Whereas once you start to see the Earth from outside, there is a philosophical view that you get when you get to encompass, so to speak, the whole world in your single vision. And this is a big deal, because a lot of people are saying, well, maybe if all these rich people who are going up there start to see this, that's not a bad thing, that they can really, more people get to experience that, and more people who, more importantly, actually have the financial means of making an impact. And maybe this is an indirect way of promoting that necessity. And, look, I'll just say this. And this is, we've talked about this before. If you could give every single dollar that we'd spend in space to improving the lives of every single human on here directly, I have no problem against that. A, we know that would not happen. And B, we also clearly, the way we're doing things isn't working. And so maybe if we try some new things, maybe we'll have a bigger impact. I mean, the data clearly shows we're not making that much progress.
Very good point indeed, Brad. Now, they did only make it to the American-defined edge of space at 80 Ks, whereas the international community agrees it's at 100. Does that dampen this achievement, Brad?
Well, so I love this point because, A, we know exactly, we'll talk about this next week, how many times Jeff Bezos is going to mention this. He's already mentioned they have bigger windows. Which this is just comical to me at some point. I kind of really find it entertaining. But at a different level, space can't really be defined in the sense, there's no physical thing that says, okay, you're in space. The microgravity experiences you get at 85 kilometers versus 100 kilometers, it's essentially the same. Like, you're not going to really notice a difference. The view will pretty much be the same. There's just practical reasons. The Kármán line people quote as saying, well, that's what the international line is. Well, technically the Kármán line varies. And this is the critical point. It varies between 80-ish to 120 kilometers. And that's the critical line that you can maintain in orbit. And you can't just constantly be changing the line based on what the atmosphere is doing. So the international community takes 100 because that's a nice round number. That's it. Like, that is the reason. There is no reason that 100 is special. The U.S. takes 50 miles because it's a nice round number. 100 kilometers in miles is 62 miles. So that's a random, pointless number. So, it's this little critical point that you get to talk about, that we define space because they're the numbers that we can remember to define space rather than anything.
All right, so when Jeff Bezos jumps onto Trekzone next week and starts touting that, I'll be sure to just play that clip back to him and just tell him to calm down.
And if he gives me $1 billion, I won't say it again.
Exactly right. He can say whatever he likes at that point.
Pretty much, yeah.
Well, look, do you think we're going to be able to book a ticket via Virgin Australia for us here in Australia, Brad, to get to suborbital space?
Well, and I think this is now the interesting thing. Now that you're kind of over that hump of doing it the first time, they can start to take place. They can start to have more regular flights. And clearly the vision is multiple planes flying in multiple places. And in fact, Elon Musk talked about this years ago with the new, I guess, what we call Starship, is that you can essentially shortcut your travel time around the world because you're just flying up and over. And something like Virgin Galactic could do this as well. I don't think it's dramatic to think that at the end of the decade, we're starting to see more planes and flights taking place from more locations. This is just what happens. And yes, it's taken 17 years to get to this point, but we see how quick and rapid progress is, especially A, when there's competition, B, they know what it works, and C, when they can think of the next development stage. So I think it's an exciting world that we can't just discount its rich billionaires having their own go at each other. We don't understand the full ramifications of what this technology may be able to do. And in 10 years' time, maybe I'm wrong, and maybe it was just a competition just to say they're first. I don't think that will be the case, though.
I think the other thing as well for Australians at the moment with the way international air travel is, 38,000 I think it is to get home from London at the moment. So 250,000 to jump into orbit doesn't seem that much of a stretch anymore.
No, look, to be honest, it's almost going to probably be cheaper at this rate. And
Yes.
Richard Branson never even left the state of New Mexico, so you didn't have to worry about any state border closures.
Fantastic. Well, Brad, next up, a 13 billion-year-old hypernova has been found by a team of Aussie astronomers at the Siding Springs Observatory.
Yeah, so something a bunch of my colleagues were involved with, which was quite cool. And that is using SkyMapper, which is this robotic telescope I've used a lot with for supernova. Is also looking at what we call middle poor stars, some of the oldest stars in the universe. And one star in particular they found believes to have matched the signatures of being created from something we call a hypernova, something that is much, much more powerful than a supernova. So a bigger star, and if that star is much bigger, when it explodes, it could create what we call a hypernova, so just a big supernova. But it produces very unique elemental signatures that they believe they detected for the first time.
Now, this star had an iron to hydrogen ratio around 3,000 times lower than the sun, and that suggests that it formed relatively close to the Big Bang itself. Can you help me understand this bit, Brad?
Yeah, so this is kind of a really cool thing, and that is hydrogen and helium were essentially what was mostly formed after the Big Bang. If you look at your periodic table of elements, the easiest thing to form is hydrogen. It's just one proton. Next is helium. You have 2 protons and 2 neutrons. So as you work your way up, it's way more complicated. It requires more energy and more stuff to create it. So it's way more efficient to create hydrogen and helium. And now iron is at element number 26, and that's kind of the end of when fusion happens. You cannot fuse another atom onto helium or another proton onto helium to get to number 27 because it costs energy. You essentially lose energy in the process. So the way that happens is you do fission. You take bigger elements and you break them apart. Think of fission bomb. But when you get to iron, or number 26, fission stops. You cannot rip something off of iron and get energy out. It costs energy. So astute observers may say, well, how did you get those big ones in the first place? You need extra energy from an exploding star. So the only way those heavier elements are created in the beginning is you have extra energy from these explosions that could make up for this essentially deficit of energy to create those atoms in the first place. So in the beginning, you just had a lot of hydrogen and helium, very little iron, and those were the first stars. So seeing that signature was this wow factor of, yeah, this had to be formed from the beginning ingredients when the other ones really weren't in abundance.
And it's certainly giving us a peek into how those first stars of the universe lived and died.
Exactly. I mean, a lot of hypernova have been kind of theoretical in that we haven't seen them. They're too big. they're too faint because they're too far away in the universe. But because they're so big, we think with bigger telescopes we may see them at some point. But yeah, this is one of the first clearest evidence that we have that they probably do exist. Because some of the stars we're talking about could be upwards of 10,000 times bigger than the sun. We're talking about gigantic stars. We do not see those stars in the nearby universe or the young universe, but they're theoretical. And if their explosions exist, well, we can see their signature. So now that we think we've seen the signature of it, what we'd like to see now is one of those explosions. And with things like the James Webb Space Telescope coming up in a few months' time and the new big 25 to 30 meter class telescopes on Earth, we think we may be able to start seeing these things in the distant universe, which is kind of a cool era to discover. So this is a good hint that we're on the right track.
And another curiosity with this hypernova, Brad, is that it doesn't match the chemical pattern of other neutron star mergers. What does this mean?
That's exactly right. When neutron star mergers come together, they create obviously a lot of these elements that we see as well, but that has a different signature. Every combination of star has their own fingerprint of elements. And that's the really great tool, is if you get to break up what those colors of light are and what those elements are, you can figuring out what kind of combination of stars that may have taken place. And that's another one of these key things that says, yeah, this came from something different altogether.
Well, lastly this week, Brad, for our stories of the week, we talked about them a couple of weeks ago, I think, but now astronomers studying 2016 data from Kepler have identified 4 new Earth-sized rogue planets.
Yeah, we were talking about how some of these rogue planets may be able to host moons that have water, and now confirmation of 4 new rogue planets. And rogue planets are really hard to find, because the traditional way is you look for a planet to go in front of its star, and then you see it exists. Well, a rogue planet means it doesn't have a star, so you don't get to see it going in front of another star. And so it's a really hard thing to show and prove. But this new analysis, he said, of Kepler data believes that they found 4 of them, which is very exciting because, again, one of these theoretical ideas that started as saying, hey, rogue planets could exist, now is starting to find really strong evidence that they do and how unique that they are.
Now, one theory for rogue planets is that they could be, essentially, the victims of a giant family squabble, this is my analogy, where heavier planets, the siblings, if you will, in their solar system, flung them away from the host star, the parent.
Yeah, exactly. That something happened in the solar system. They don't form out of nothing. They form in a solar system or a star system, and something happens where, as you said, they get the boot. And so this is kind of the interesting thing, is it's not like you can look for a pocket where you expect an entire solar system to have planets without a star. The star will form, and then the planets. So something cataclysmically kicked this thing out, and went off into space. But you don't know how long that is. Was it 1,000 years ago? Was it 10 million years ago? You can't really pinpoint when that emission is. So it's not like just saying, oh, here's a star, we're going to look around here for rogue planets. It could have been anywhere in the distance it traveled, and how big the kick was. Did it just get a little boot, or did it really get flung out of the solar system?
Was it a middle child or the new kid on the block?
Marsha.
Rogue planet discoveries are incredible feats of scientific achievement, Brad, especially when you consider just how much effort it takes to spot a regular old exoplanet transiting its star. So the fact that we've seen a few now is pretty cool.
Yeah, that's right. When you're confirming planets, you need to really at least have 3 clear detections of it. So when you're looking for a transit, you're looking for 3 dips around it. And this is why we're biased towards finding planets very close to their star, because they go around so quickly, we can see it multiple times. Finding things like Earth, where it only goes around every year, means you have to wait 3 years. If you're waiting for the Jupiters, you're waiting decades. If you're waiting for the Plutos, you're the better part of a millennia to try and see it a couple of times. So as you said, it's a really big achievement to try and find any of these, let alone 4.
Well, rogue planets are going to be a major focus for the forthcoming Nancy Grace Roman Space Telescope. Can you tell us a little bit about this mission, Brad?
Yeah, so originally called WFIRST, it's a Hubble-class telescope that is going to look into the infrared colors of light. And so by looking at the infrared colors of light, you can start to see cooler signatures of light. when we look at stars, they shine mostly in the optical colors, the colors we can see. Infrared light is much cooler, which means it's kind of blocked out, so to speak, by some of that brighter, hotter light. So if you have a telescope that can focus on those infrared colors and see that cooler light, you can pick up the signatures easier of these planets because they do emit a little light and energy, just not a lot. So it's usually drowned out kind of by the other color. So if you're really focusing on this cooler light, you'll be able to see these signatures that we would normally miss. Or in particular, things that are around a lot of dust. When we talk about dust, we talk about the building blocks of planets. Well, that blocks out light as well. So we can often look at a place where there seemingly is no light. We can look through the infrared and we look through that cooler light and all of a sudden we see a bunch of things. So it's really opening up a new way of looking for signatures that are cooler in space.
Alrighty, Brad. Well, just before we go, a look ahead to this week's Talkin' Science interview. Dr. Amy Parker is beaming in from the CSIRO. She's going to give us the lowdown on how having direct access to Novastar 1 will improve Australia's use of Earth observation data. Something that was taking up to 40 days to process now takes just an hour. Dr. Parker, this is the first time we've managed our own source of Earth observation data. How have industries like primary producers and natural disaster managers gone about this in the past?
Yeah, good question. So we are, as a country, Australia, we are one of the world's biggest users of Earth observation data by volume and variety. So we use this data to do, it plays a huge role in our everyday lives, even if we don't necessarily realize it. And traditionally, all of that data has come from satellites that are operated by foreign space agencies or commercial providers. And this is sort of our first step towards having a sovereign Earth observation capability. So it's the first time that we are managing our own source of Earth observation data, downlinking that, processing it, and distributing it to users.
Very, very cool stuff. That interview is out now for members, so join up and get early access to that right now. Or if you're watching us in the future, click the card in the top right of the video or follow the links to our website at trekzone.org. Brad, great to pick apart the stories of the week with you as we do every week. We'll do it again next week.
Thanks. Take care.
Keep up to date with Twitter. Catch new podcasts daily on YouTube. Plus, we're beaming to your favorite podcast app 5 days a week. Just search for Trekzone and subscribe.